So, good morning, respected jury members, my teachers, and fellow students. I am Ayush Prasad from IIEST Shibpur, representing Team E-02. To start with, I'll start the presentation, and eventually my teammates Abhishek Shaw and Abhishek Das will take over. The talk is divided into four major aspects. The first is introduction and features. The second one is the structural arrangement, drawings, and analysis, followed by the design components, and finally the work plan and cost calculations. The project is designed in an area of 50 meters by 35 meters, having the advantages of flexible design, cost effectiveness. Along with that, we have also followed the guidelines issued by Ministry of Health and Family Welfare by the National Center for Disease Control for design of a quarantine center. Another key aspect of the project is its ability for utilization post pandemic wave. The problem statement issued by INSDAG is clipped here. The design method used is the limit state method, and we have tried to use hollow sections in the structure so as to reduce the self weight of the structure, and using these we have found triangulated space truss elements for the roof truss. Isolated footings are used for footings. For walls we have used FRP sheets, and all the design and analysis part has been carried out in STAD Pro Connect Edition software. Some of the key features of this model include the economy, which is very much well supported by the use of pipe sections and laced columns. Space frames and curved roofs impart aesthetic beauty to this presentation, to this structure. As the column spacing, the spacing between two columns is large, after the pandemic wave, this thing can be used as a small indoor stadium, giving it an ability of post-pandemic reuse. Moreover, special attention to the comfort of patients have been given by use of FRP sheets, Teflon sheets, which are very easily sanitizable and changeable. Moreover, we are focusing on environmental friendly construction. The expected time for completion of this project is only 45 days, and a detailed Gantt chart is attached in the upcoming slides. This brings us to the next phase of presentation, that is structural configuration and analysis.
Before going into the design and analysis part, let us first see the structural configuration in the following slides. This is the proposed orientation plan of the project showing the doctor area, toilet area, and the patient area. Next, we have column orientation showing two types of column as back-to-back ISLC 150 and two back-to-back ISMC 250. Finally, we have the front elevation, which is showed at the ends, and side elevation. After the structure configuration, now is the time of load calculation, and it is done for the structure using dead load as per IS 875-9087 part 1, imposed load as IS 875-9087 part 2, and the wind load is calculated as IS as per IS 875 part 3 2015, and also cross-checked with the determination of the wind load for arch roof JD Homes IIEST Institution of Engineering Australia.
The wind load calculation has been done by IS 875 part 3 2015, and it is further cross-checked with taking reference of JD Homes and IIEST by an Australian manual. This is the clause which said a slight difficulties can be faced when we are seeing and designing by curved roofs following IS 875. This is a clipping. When coming to seismic load, we have performed response spectrum analysis for the structure for 12 modes, and the response of the structure has been clipped in the PPT of various views. This is the isometric view of the mode 1, and in this vibrations are in XZ plane in the transverse direction of the structure. This is the vibration for the same mode but in elevation. This is the mode of vibration in XZ plane but along the longitudinal direction of structure, and this is the isometric view. And the Elevation response for the same mode of vibration would look something like this.
For temperature load as per the provision of clause 8.10.3.2 of IS 800-2007, no requirement of expression joint was suggested, so we haven't provided. Now coming to the design part of the project, it consists of three major aspects: substructure, superstructure, and connection. Now, first of which is gravity load resisting system consisting of roof truss and column, and the second is the lateral load resisting system consisting of knee and gable bracing. The roof plan of the truss is shown in this slide along with purlin and columns. Now, arrangement of the roof truss or space truss is clearly depicted in this figure. One of the main reason of choosing the space truss arrangement is that it looks good and eye pleasing but not also heavy due to the hollow tubular section. Now, space truss is designed against both compressive strength and axial tension. Here is the design calculation of the top chord and the bottom chord as per IS 800-2007 against compressive and tensile force. After the roof truss, now is the time of design of purlin, which is done considering the load as UDL on a simply supported purlin, and this is a rivet render output of the truss following sewing purlins. Purlins is designed against both compressive strength and axial tension. Here is the design calculation of the purlin using hot roll section table 10 IS 800-2007. Last but not least of the gravity load resisting system is the column, which is designed as the laced column as to reduce the amount of steel used, with making sure that the structure hold safely against different type of load, mainly acting as axial comprehensive. Column is designed to calculate cross-section strength against both material failure and buckling along with the design of lacing and bolt which is used to join the columns. Here is the design calculation of the column using two ISLC 150 back to back and as per IS 808-9087 against compressive force and tensile force. Here is the design calculation of the lacing and the bolt as per clause 7.6.3 IS 808-2007.
The main elements to take the lateral loads are the bracings. In our structure, we have two types of bracings, knee bracing and gravel bracings. Design check for bracings are done for tension are yielding of cross section, rupture of net section, and block shear strength. For the compression, we have checked for buckling, slenderness, and cross section yielding. Here is the detailed calculation of bracing. Next, we have the design of connection. Our truss is mainly having welded connection. Welded connections are rigid and lightweight. There is no hole required for the fabrication of welding. Thus, the gross area of the sections will be acting as effective area. Welded connections are done as per CID ECT manual and strength is calculated as per the clause 10.5.2.3 of IS 800-2007. Here is the detailed calculation of welding. Here is another detailed calculation. Now come to the substructure. In the substructure, we have footing, base plate, and anchor bolts. Here is the calculation for pedestal and footing with 85 kN of load, and this is the calculation for pedestal and footing with 102 kN of load. We have checked the footing for one-way shear, two-way shear, and bending moment. This is the calculation for base plate with 85 kN of load, and this is for 102 kN of load. We have checked the base plates for moments and upward pressures. For the anchor bolts, these are designed and checked for bond stress with the concrete and shear.
Now we come to the final part of the presentation, that are sample drawings. This is the architectural plan of the proposed structure, followed by front elevation, side elevation, plan of truss, foundation plan, and also the grid plan, lacing system. Now will see some joints. This one is a K joint. This one is a double K joint. This one is a TK joint used in the structure. This is the pedestal and footing. And this is the column top. This will be joining the column top as well as the roof structure. Now we will be looking at some of the Revit rendered output of the proposed structure. in different views. This is the outside view, followed by the top view at night. Then comes the sectional view at the different daytime. This is somewhat how the interior of the proposed structure will look like. The truss is somewhat like this, and footings in this way. The work plan, the expected time for completion for this project is 45 days, and this is depicted in this detailed Gantt chart depicting the work plan schedule. The cost of completion for this project is around 68.32 lakhs, and this cost has been calculated as per taking the references of whatever rates were put upon commercial websites. Along with that, a few quotations. All of the details have been mentioned in the report. A few observations which we could see here in this structure is, as per the design statement, we were set to use galvalume sheets for roofing material. But if we use that sheets for roofing material, in turn the heat of the structure will increase, and that will cause discomfort to patients. So we are making a suggestion for use of thermally insulated metal roofing sheets, which will provide a better comfortable environment inside the structure. Moreover, we can use fiber reinforced polymer sheets which will be of transparent nature into alternate spans, so as to increase the natural lighting of the structure. Moreover, we can further use ball and socket joints for connections. These joints are, however, not used in the structure because of availability issues in different parts of the globe. The key references and the manuals which we referred for designing this project are listed in this slide. And I would like to thank my mentor, teachers, fellow mates, as well as INSDAG to provide us this opportunity for presenting this presentation and designing the structure. Thank you, one and all.